So how do we estimate errors in our measurements? So the following are the different ways in estimating errors. So we can look for the absolute error, we can look for the percent error, we can look for the percent difference, and variance and standard deviation. So let's define the following and study the examples given. So absolute error with the symbol delta E is the difference between your obtained or experimental measurement and accepted measurement. So the mathematical representation for this definition is this one. So absolute error or delta E is equal to x of E minus x of A within, so inside the absolute bars. Yan. Absolute sign. So where x of E is your experimental or obtained value, yung ikaw mismo yung nag-measure, and the x of A represents the accepted value or the true value of the measurement. Absolute error is the measure of how far is your obtained measurements to the accepted value. So gaano siya kalayo, gaano siya kataas or kababa compared doon sa true value. Next is percent error. So it is the absolute error divided by the accepted value multiplied by 100. So mathematical representation, we have this. So this is the absolute error. So x of E minus x of A. Ayan. So kung titingnan mo dito, this is absolute error. X of E minus x of A. So we can also write here delta E divided by x of A. So if the given is already delta E. Times divided by x of A times 100, where x of E is your experimental and x of A is your accepted value. So percent error measures how large or how small is your measurement relative to the accepted value. So percent error measures the accuracy of your measurement. So it measures how big of a part is your error of the accepted value. So on the other hand, percent difference is a measure of precision. So dito, diba, we compare in absolute error and in percent error, we compare the error to the true value. We compare the errors to the true value. So that gives us the idea that the absolute and the percentage error measures the accuracy of measurement. So percent difference naman, it measures the precision of measurements. So to calculate for the percent difference, we get the absolute of the difference between two experimental values. So if you have 3 trials, so kunin mo yung measured value ng trial 1, measured value ng trial 2, and then apply this equation to those values. So x of 1 for first experimental value, x of 2 for second experimental value, then divided by the average of the two experimental values times 100. Again, percent difference compares two experimental values and it measures the precision or how far apart are your obtained values from each other. If percent difference is large, then there is also a big difference if the percent difference is large, then your measurement is not that precise. But if the percent difference is small, then your measurement is considered to be precise. So depending on the value of the percent difference. So let us have an example. So 3 trials were performed to determine the distance between building A and building B. So the first group measured it to be 503.5 meters, second group measured it to be 502.8 meters, while third group measured it to be 497 meters. So if the actual distance between A and B, yung totoo, the true distance between A and B is 500. So what is the error? So ano ba yung mga error nitong mga obtained values natin? And the percent error. And letter C, what is the percent difference? So by comparing, so what is the percent difference between the experimental values? So let us represent this information in tabular form. So tabular representation will help us compare the values easier. So trial 1, we have here trial 1 and experimental value 1. So x of 1 is equal to 503.5 meters, x of 2 is equal to 502.8 meters, and then x of 3 is equal to 497.4 meters. So to get the error, to solve for the error, we simply subtract the actual value, accepted value from our experimental value. So 503.5 minus 500. So let me use my laser pointer. So here. So 503.5 minus the accepted value 500 is equal to positive 3.5 meters. 502.8 meters minus 500 meters is equal to positive 2.8 meters, and 497.4 meters minus 500 meters is equal to negative 2.6 meters. So now, what is the meaning of the positive and negative sign? So this positive and negative sign will give us some important information. So when the value of error is positive, then your experimental value is higher compared to the given or to the actual measurement. While when your error is negative, then your experimental value or obtained value is lower compared to the actual measure. So here, so 503.5 is 3.5 higher than 500 meters. 502.8 is 2.8 meters higher than 500 meters, and 497.4 meters is 2.6 meters lower than 500 meters. So to get our absolute error, so we just simply get the absolute of these values of error. So absolute values, absolute errors are positive values of the errors. So dito, instead of negative 6 at 2.6, nagiging siyang positive 2.6 meters. So we use the absolute error to look for the percent error. So here we have the values of the error associated for each of our experimental values. So knowing the absolute error is of course important, because we will know how high or how low our experimental value or our measured value compared to the actual value. But what is more useful is to know how big of a part is this error compared, how big of a part is this error compared to our actual value. So gaano ba kalaki itong error na to compared to the actual value. So we can calculate that by using the percent error. So percent error is equal to the absolute value or absolute error divided by the accepted value multiplied by 100. So we already have our value for the absolute error. So for 503.5, the percent error is 3.5 divided by 500 multiplied by 100, so we get 0.7%. So meaning 3.5 meters is 0.7% of 500 meters. So it is relatively small. Ayan. So for trial number 2, experimental data 2, 502.8 meters. To know how big of a part is this error compared to this one, so we divide 2.8 meters divided by 500 times 100, we get 0.56%. So 2.8 meters is 0.56% of 500, while 2.6 meters divided by 500 times 100, so 2.6 meters is 0.52% of 500. So the next question now is that so paano ba natin iintindihin tong number na to? So by looking at this number, so kailangan ba natin mag-alala? So for example, kailangan ba natin mag-alala dito sa 0.7% na to? So sabi natin 3.5 meter is 0.7% of 500. So ganito kalaki yung error natin. So ganito kalaki yung 3.5 meters na error. So do we need to worry, or do we need to do something in order to reduce our error, or is the error acceptable or not? So yun. So let us change the value of our accepted value. So here in our next slide, we have here the accepted value. So this accepted value is the same as the previous, which is 500, and then the absolute error, we use the absolute error for trial 1, so 3.5. So for example, this one. So for example, for the absolute error, we want to know how big of a part of 500 is the error equivalent to 3.5. So we already know that 3.5 is 0.7% of 500 meters. So do we need to worry about this one? So titignan natin, kung titignan natin just by looking at the value, so pwedeng sabihin natin na we don't need to worry about this value of error. But what if the accepted value is 20 meters? So how big of a part of 20 meters is 3.5? Gaano ba kalaki si 3.5 in comparison to 20 meters? So 3.5 divided by 20 times 100. So ibig sabihin 3.5 is 17.5% of 20 meters. So look at this value. So, 'di ba? So dito yung 3.5 can be relatively small. So 3.5 is a small value relative to the actual value of 500. Pero dito 3.5 is a big value. Is a big error relative to the actual value, which is 20 meters. So yan. So sabi natin dito 3.5 is 17.5% of 20 meters. So this is a relatively large error. Ayan. So let us now move on to letter C. So percent difference of the measurement. So again, percent difference is a measure of precision, and to calculate for the percent difference, we make use of this one, of this equation. Percent difference is equal to x plus 1 minus the absolute of the difference between x plus 1 minus x of 2 divided by the average of the two experimental values times 100, where x1 is experimental value 1 and x2 is experimental value 2. So for example, we have 3 trials, and our x1 is 503.5 and our x2 is 502.8 meters. So we want to know how big is the difference between 503.5 and 502.8. So how far apart are these numbers from each other? So we can use percent difference. So by applying the calculation, Yan na. So, sinubstitute natin x1, 503.5 minus x2, which is 502.8, divided by the average of the two experimental values involved. So, times 100. So, we get a percent difference of 0.1391%. So, to answer how big is the difference between these two values, so the difference is 0.1391%. So, yun ang difference nila. So, this is a relatively small percent difference. So, hindi sila masyado nagkakalayo. So, 503.5 meters and 502.8 meters are not that much different from each other. So, you can also apply this. For example, x1, compare the value of experimental value 1 to experimental value 3. So, x3, kasi kanina meron tayong 3 trials. So, pwede mong i-compare ito. So, si x1 to x3 or x2 to x3. Ayan. So, you can compare. So, between two experimental values in your data set. So, in our next video, we will learn how to estimate the errors if the actual value is not given or is unknown. Because here, in our example, for the percent error, for the absolute error, and for the percent difference, the actual value or true value is known. So, ayan, for example, dito, given si 500, and this one given si 200. So, we can compare our error with the actual value. But, what if we do not know? So, what if the actual value is not given or is unknown? How do we estimate the errors? So, that will be discussed in the next video. So, thank you for watching.